right, remember here we have -1 to power um, k plus 1. So I'll just ignore it because remember we're going to use ratio test, which involves taking absolute values. So there's no point of really including -1 here. Simplify working out. So a sub n will be equal to a sub k, because you have k in this case. So a sub k will be equal to k factorial over k to power k, and a sub k plus 1 will be equal to k plus 1 factorial over k plus 1 to power k plus 1. So after that, what we can do is we can go ahead and find the limits. So the limit as n approaches infinity of the absolute value of k plus 1 factorial over k plus 1 to power k plus 1 divided by k factorial over k to power k. This will be equal to the limit as n approaches infinity of the absolute value of k plus 1 factorial over k plus 1 to power k plus 1 multiplied by k to power k over k factorial. Okay, and then what you can do is just rearrange this, guys. Easier for us to work with. So the limit as n approaches infinity of the absolute value of k plus 1 factorial over k factorial multiplied by k to power k over k plus 1 to power k plus 1. This will be equal to the limit as n approaches infinity actually this is not n, it's supposed to be k. Apologies. So anyway, we end up with so this will be k plus 1 multiplied by k factorial over k factorial multiplied by k to power k over k plus 1 multiplied by k plus k plus 1 to power k plus 1. All right, so what we'll end up with here is these guys will cancel. So what we'll end up with is the limit as k approaches infinity of the absolute value of all right, now if you look at these guys here, we can simplify them. You know, k plus 1, you know, if you apply indices, you can simplify those guys. So what we'll end up with is something simpler actually, because this will be we'll end up with k to power k over k plus 1 to power k. All right, if you simplify those, you'll end up with that, which will be equal to the limit as k approaches infinity of the absolute value of k over k plus 1 to power k. All right, now we've been given way up here, that the limit as n approaches infinity of 1. So this is equal to e. So we kind of have to find a way of, simplifying this guy to make it look like that. So this will be equal to the limit as k approaches infinity. You can write this as now we need to rewrite that. What you can do here is, that if you have a over b to power m is the same as 1 over b over a, all this to power m. So I'm going to use that idea to simplify this. So what we'll end up with here is the limit as k approaches infinity of 1 over so 1 over k plus 1 over k, all this guy to power k, which will be equal to the limit as k approaches infinity of let me just ignore the absolute values, then you can see what I mean here. So k plus 1 over I can simplify this to have 1 plus 1 over k, if that makes sense, all to power k. You have the absolute value signs. Anyway, as k approaches infinity, this will be what the statement up here is saying, is that 1 plus 1 over k will approach to e. In fact, I can simplify this statement again, just make it simpler for you. The limit as k approaches infinity of the absolute value of 1 to power k is just 1, so I'll have 1 over 1 plus 1 over k to power k, and then what I'll end up with is the limit as k approaches infinity of 1 over making it really long here, limit as k approaches infinity of 1 plus 1 over k to power k, and that will be equal to 1 over e, because at the top here will be, assume that the limit, this is actually an exponential limit, right? It's an exponential limit, and you can use that exponential limit to basically simplify the last bit to end up with 1 over e. Now 1 over e is less than 1, which means that we can conclude and say, hence the sum from k is equals to 1 to infinity of negative 1 to power k plus 1, k factorial over k to power k converges absolutely. Because the limit of absolute value of s sub n plus 1 divided by s sub n is less than 1. All right, it's a long solution, but you have to be familiar with this type of questions. So I'll carry on to the next example. And the next example is, again, we are doing the same thing. use ratio test to establish whether or not the following series converge absolutely. And we have this guy here. So my A sub k will be 2k factorial over k factorial squared. And A sub k plus 1 will be equal to 2 into k plus 1 factorial over k plus 1 factorial squared. All right, so what you're going to do is to use these guys to try and establish whether this series converges absolutely or otherwise. Anyway, so let's start. The limit as k approaches infinity of the absolute value of 2 into bracket k plus 1 factorial over k plus 1 factorial squared divide by 2k factorial over k factorial squared, and we can carry on and say the limit as k approaches infinity of the absolute value of now this bit can be written as 2k plus 2 factorial over I'll expand this. This is same as actually I can just leave it like that before I can simplify it. So k plus 1 factorial squared multiplied by, take the reciprocal, k factorial squared over 2k factorial. And then I'll end up with the limit as k approaches infinity of I'm going to rearrange a few things here. So here I'll have 2k plus 2 factorial over 2k factorial. In fact, let me just expand this. There's no point of having an extra step. So 2k plus 2 multiplied by 2k plus 1 multiplied by 2k factorial over 2k factorial, all right, multiplied by so here I have k factorial squared over, now the bit at the bottom I can expand it as k plus 1 multiplied by k factorial, all this squared, if that makes sense. And then I can simplify this bit. And by the way, this cancels, so that's gone. Here, what I can do is, instead of writing an extra step, this squared, actually, I'll just include an extra step. No need to include everything in one step. So this will be equal to the limit as k approaches infinity of the absolute value of 2k plus 2 multiplied by 2k plus 1 multiplied by, now what I have here is k factorial. This is squared, sorry, mix things up. This is squared. So k factorial squared over k plus 1 squared multiplied by k factorial squared. Okay. That and that bit cancels. So what we'll end up with is limit as k approaches infinity of the absolute value of 2k plus 2 multiplied by 2k plus 1 over k plus 1 squared. You can expand this bit to end up with 4k squared plus 2k plus 4k plus 2 over k squared plus 2k plus 1. All right. And then we shall end up with 4k squared plus 6k plus 2 over k squared plus 2k plus 1, which will be equal to 4 by LHR. All right. So, because our limit is equal to 4, which is greater than 1, we can conclude and say that this series diverges. Hence, the sum from k is equals to 1 to infinity of 2k factorial over k factorial squared diverges by ratio test.